105 when we're done. Make sure I have the right one up. Yeah. Okay. Oh, did I just do that? Okay, 105. And your parent functions for sine and cosine. To understand something about these so that we can make this graphing process very simple. Some of the terminology that we need, this distance from this maximum value to here, the amplitude, right? It's half the distance between the max and the min, but if there's no vertical translation, then it's also the distance between the x-axis and the maximum or minimum values. And then the distance from here to here is the period. So one cycle is one period. Same thing goes for cosine. So this distance is the amplitude. And although most of you that had cosine, when you were trying to find the length of a sine yesterday, you were starting like from here to here, which is fine because you can actually start anywhere on the graph. Most in thinking about cosine is still thinking about it from 0 to 2 pi so that it has a different shape and a different look than sine. So this is a period. Okay. Now, and as we talked about yesterday, any cosine graph can be made into a sine graph by just doing a horizontal translation, right? I translate it to the left or to the right, depending on what's going on. Pi halves, and it's now a sine graph, okay? And so that's what the next part of this stuff here says. It says, notice that the cosine function is a horizontal translation of the sine function. Any transformation of a sine function is called a sinusoid. Therefore, sine and cosine functions are called sinusoidal functions. So that's terms that you will hear, in the future stuff. Functions that repeat regular intervals are called periodic functions. So it's a sinusoidal function. It's also a periodic function. Not every periodic function is sinusoidal. They don't all, go together like that. So let's look at these definitions. The period is going to be the length of a cycle and it can start at any point on the graph. So it doesn't matter where we start, but again, when you're thinking parent functions, going from 0 to 2 pi for these two are going to be what's going to benefit you the most. And then the amplitude is half the distance between min and max values. Okay, everybody okay with all that? So we're going to start with some basic transformations. We're not going to do everything all at once. So when we wrote down transformations yesterday, I gave you the A, B, C, and D all in one big thing. Well, that's when everything is thrown in there. But we're going to start with just the amplitude and the period. So we're just looking at the vertical and horizontal stretches and compressions. So that's why there's just A and B in here right now. We could always add more. So A, which is your vertical stretch or compression in any transformation that you've done so far, is called amplitude for trig, or for sine and cosine anyway. And so it's the absolute value of A, because the sine does something else to it, right? And then the period is based off of B. Well, the period for a parent function is 2 pi. And B, the x lies just like it does for any other transformation. So we're really using 1 B. 2 pi into consideration, so it's 2 pi divided by the absolute value of B. Okay. Two very simple things to figure out that we need to know to be able to graph these. Okay. So if I look at number one, all we're doing is identifying the amplitude and the period right now. What is the amplitude in number one? Right? It's 1. That's all it is. And then period, what's the period? I find it. It'll be over what? 4. And then what does that reduce to? So the period is pi halves, the amplitude is 1. 2 pieces of information we need to be able to graph. All right, number 2, what is the amplitude? 7/2. And what is the period? What's B? 1. B is 1. So that means the period is 2 pi, because it's 2 pi over 1, it's just 2 pi. Okay. That just means the period wasn't affected, because just in the parent function it's 2 pi. All right, you work on 3 and 4. See if you can come up with the amplitude and the period. All right, number 3, what's the amplitude? 5. Positive or negative? Positive, because the absolute value, right? What's the period? No, not 2 pi over 3. 6 pi, good. Because it is 2 pi divided by 1/3. Not that you have to write this part down, but when you divide by 1/3, you get 6 pi. What's the amplitude in number 4? 2. And the period? 3 pi over 2. Okay. Everybody okay with all that? Any questions at all right now? All right, let's graph. Okay. So we still have to identify the amplitude and the period and then graph the function. So in number 5, what's the amplitude? 2. And what's the period? 2 pi. Okay. And then here is the parent function. This is sine, so the parent function looks like this. All right. Well, more symmetric than what I just drew, but I was running out of room at the top. Okay, so there are 5 key points, anchor points that you need to be able to plot the X-intercepts and the maximum and the minimum in one period. Okay, so that's the parent function of just one period or one cycle. So for sine, with the X-intercept or the Y-intercept is 0, 0, and when I multiply, it doesn't change anything. It's still 0, 0. There's no vertical or horizontal translations here, so 0, 0 is going to be it for sine every time. So it's best to do these in a methodical way and always go about it the same way. That way when things change and get weird, you can still just go about it with no big deal. I would plot this first point, and then the next thing I would do would be the end of the period. The period is 2 pi. That's where this point goes, and it's an X-intercept, so I'm here at 2 pi. Everything is symmetric. It stays that way. So this one right here is halfway in between those two. So halfway between 0 and 2 pi, you're at pi. There are your 3 X-intercepts right there. Okay, everybody okay with that? Then I need this maximum point here. Well, the X value is halfway in between these two, which would be at pi halves. The Y value, because the distance from the axis up to the maximum is 2, because that's the amplitude. So I go from here and I go up 2. And I'm right there, and I've got this point taken care of. Then I'm going to plot this point. So it's halfway in between these two, and I'm down at -2. And I've got all 5 of those points plotted. Okay, everybody okay with that? Once you get those done, it just repeats. So this is what it looks like. It's coming like this, so that it's going to go back down. I would just go ahead and do all of my X-intercepts. I'm at pi, and then a negative pi. And these just alternate between being up and down. So this one's down here. This one's up here. You got everything you need, and you sketch it in. Okay. Any questions at this point? Okay, I don't expect them to be perfect, I never do, but make sure they're not pointy. Like it can't look like a zigzag. You have to make an effort to make it curvy and smooth and not pointy and jagged. All right, let's look at number 6. Amplitude. 5. What's the period? 4 pi. Right? And this is cosine. So your parent function, one cycle of the cosine graph looks like this. And we have, again, 5 points. We have 2 maximums, a minimum, and 2 x-intercepts. Those are those 5 points that we're going to get plotted. We should know where they are on the parent function so that we can easily get them onto here. So for cosine, when you're at 0, for the parent function, you're starting at 1, but your amplitude is 5. So I'm up here at 0, 5 is where I am on the y-axis. Okay? That's this point. So this point right here is going to be at the end of my one cycle, at the end of the period, which is at 4 pi. I can't graph it because it's way off the paper, right? So I don't get to graph that one. That's okay. We're not always going to get to put them all on there. But the next thing I would do then would be the middle one, right? And so that's halfway in between 0 and 4 pi. So the x value would be at 2 pi. Yes? What would the y value be for that? -5. Good. Because your amplitude is 5 and this is your minimum. So I got that one taken care of. Everybody okay with that? So then my next one would be my intercept. It would be this one. It's halfway in between 0 and 2 pi. So it would be at pi and on the axis right here. So I'm not going to get to graph that one there either. All I get are these 3. So it looks like this. And see, it would continue up and go like this off my graph. I just can't do that. Okay, does that make sense to you? So then we come up and we're going to come back down. I'm going to hit the x-axis over here at -pi. And at -2 pi, be at -5. So this has been stretched out and stretched up. So it looks like this. But better. That's all. Y'all should always look better than mine. Okay. Any questions at all? So we were able to graph one full cycle. It's just not in the, from 0 to 2 pi, and it's fine. Okay, we good so far? Let's do another one. It'll turn out a little bit different. Number 7, what's the amplitude? 3/2. And what's the period? Pi-halves. So then this is cosine. This is one cycle of my parent function, right? So I have those 5 points. I want to start with this one right here. So that usually starts at 0, 1, but my amplitude is 3/2. What else is going on in this function that didn't happen in the other ones? It is going to be compressed and it's negative. It has a negative. So what is this negative going to do? Reflect it. Is it reflecting the x or the y? The x. It's going to reflect in the x-axis. So although my parent function would start at 0, 1, but really it's 3/2, so it'd be really 0, 1.5, that negative reflects it in the x-axis, so it ends up down here. So that's this point here that I just graphed. It's a maximum in my parent function. It's a minimum here because of the reflection. Everybody good with that? So the next thing I want to do is the end of the period. Well, the end of the period has the same y value as the beginning. Pi-halves. So here's pi halves. There's the end of one period. The minimum value, which will turn into a maximum because of the reflection, is halfway in between those two, right? So it would be on this x value. My y value is 1.5. Now, your x values are like pi-halves, pi-fourths, pi-eighths. They're going to be all weird pi numbers. That's one reason why we don't want to do a t-table here, because you're going to get weird values that you're not going to have a clue how to graph. And it's okay, because you don't need to. If you understand the symmetry of the graph, you just go halfway, 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 and you figure it out from there. Just make sure that you're paying attention to the units on the graph. All right, so I've got those two. Now I need these in-between ones. Well, halfway in between these two is literally halfway in between right there on the x-axis. That's this point. Then to get this point, it's halfway in between right here. So it's reflected upside down and it's squished together, but it's basically that, and I've got my 5 points. Everybody good with that? Once you've got those 5, then before you draw anything in, I would just repeat what's going on. Your X-intercepts are only one space away every time. So they're in every single one of them, and you have a lot of them. Okay, so you can get all of your X-intercepts in there. And then your max and min values are go in between those, and they just alternate between being a maximum and a minimum. And it just goes on every other one there. And they'll have arrows on the end because they're going to continue. Okay? So it looks something like that. All right, number 8. What's the amplitude in number 8? 1. And the period is? What? 3 pi fourths, good. 3 pi fourths. So this is sine, which means it's going to look like this for one cycle. Got those 5 points I want to do. So 0, 0 is just 0, 0. So that's this point. The end point of the cycle is going to be at 3 pi fourths. Well, this is pi, and that's 1, 2, 3, 4 pi fourths. So right there, that's 3 pi fourths. So I have the beginning and the end of the cycle. The other x-intercept right here is halfway in between. So this is 3 pi fourths, which means that's at 3 pi eighths. And then halfway in between, that's going to be at 3 pi sixteenths. But that doesn't really matter. Like, you should be able to figure those things out and be able to tell me that. You should be able to do it, but you're not going to be like getting decimals and guessing it that way. I want to go halfway. Yes, it's going to be at 3 pi sixteenths, but this is also 1.5 spaces to get to here. Would you agree with that? What's half of $1.50? 75 cents. So you got, instead of going 1.5 spaces, you're going to go 3/4 of a space, and my amplitude is 1. There is a reflection though, so instead of it being a maximum, it's going to be a minimum at -1 is my y value, but I'm here at 3/4 of the way to 1 space for my x value. Okay, so if you think about it in terms of the grid, it's going to be a little bit easier for you because that's all we really have to be able to do for the graph right now, but you should also easily be able to figure out the values if you need them. Okay, so then halfway between these two is going to be, it was a minimum, but it's a reflection, so it's going to be a maximum. Well, again, it's 3/4 away over, but I'm hugging the other side of the line, so it's like this. So I'm hugging the opposite sides there. There are my 5 points. Everybody okay with that? The next thing I would do would be go in and get all my x-intercepts in there because it's every 1.5 spaces. Oh, that is not what I just did. Come on. There we go. So every 1.5. Like so. And then you're going to alternate your max and mins. Just make sure that you're hugging the correct side of the the line that you're trying to do. It should look something like that. Okay, any questions at this point? Did I lose anybody anywhere? Speak now. Okay, let's look at number 9. What's the amplitude of number 9? 5 halves. And the period is 3 pi. Good. All right, so go ahead. I want you to plot your y-intercept. All right, what is your y-intercept? 0 what? Negative 5 halves. Because this right here is, my amplitude is 5 halves, but this is a reflection. I usually start at 0, 1, right? But my amplitude is 5 halves, so it's like 2.5, but that negative reflects it down here, so I'm at negative 2.5. For this point right here. So once again, my maximums becomes minimums and vice versa because there's a reflection. So that's the beginning. The end of my cycle is at 3 pi. I don't get to graph that because it's not on my grid, right? So I know that this point right here I can even do because it's supposed to be at 3 pi. Can I graph this point? Yes, because that's halfway between 0 and 3 pi. What's halfway? 3 pi halves, right? Because you just, 3 pi over 2. So that we should know is halfway between pi and 2 pi. So my x value is 3 pi halves. My y value is what? 5 over 2. And it's positive because that was a minimum. It reflected and became a maximum. Okay. So I got that one. I can get this one because it's halfway, right? Halfway between 0 and 3 pi halves is 3 pi fourths. So my x value is 3 pi fourths. My y value is 0. Am I able to plot this point right here? Yes, because it's right there, right? Down there. So I was able to get 4 of those 5, which is enough for me to get what I need to repeat. Yes? Any questions? Okay, so let's try and fill in the rest of this. So I can see that I'm coming up and going down. I'm going to come back up. And so at negative 3 pi fourths is where I would have my x-intercept. Negative 3 pi halves. And then there's the point. Okay? So then it's going to look like this. Okay. Any questions? All right. So I want you to work number 10, 100%. I will talk you through it because all day I've needed people still for me to talk them through it in the end. But I want you to have it 100% done on your own. So I'm going to give you time to finish number 10 or do number 10. I'll pass out the homework, take attendance, and then I'll talk you through it. All right, so this is sine, no translation, so I know 0, 0 is the starting point. The period is the length of pi. So that what that means is I have to complete a full cycle that looks like that from 0 to pi. So that's the end point. I have these 2 points plotted right now. Okay, to get this other x-intercept that's halfway in between, that's right there. So now I have that point. There is no reflection, so I don't have to, so my maximum is a maximum. So in between these two, halfway, I'm going up to not 1 like the parent function. My amplitude is 4. I'm going up 1, 2, 3, 4. And then between these two, I go down 1, 2, 3, 4. There are my 5 anchor points. Okay? And if I can get those 5 done, then I can do everything else. Go put in the rest of my intercepts. And then I'm going to alternate with these. So that it looks like this. And that's just like a ton of points, right? And you got to go and get your graph in there. Ugh, this one's not good. My curve is bad, so always make sure your curve looks better than mine does. Hit the points better. Ugh, I'll start over. Maybe. It's probably not going to be any better, but. There we go. Okay, everybody good? Any questions? All right, so go ahead or glue or tape this in, and remember on the assignment, don't even touch the tangent graphs yet, but the sine and cosine ones, you should be able to get quite a few of them graphed before the end because they go pretty quickly, and I'll check them for you.